What are you talking about?
Good, Desmos.
So crazy.
Okay, Anthony, you got that equation written?
I'm still writing.
No, dude, we're 8 minutes into class. You should be done writing that down. We should have an equation done or almost done. It's okay to talk, but that talking needs to be about the mathematics in front of you. Hold on 1 second. Who else was absent yesterday? What's up? Did you say you had a question? Okay.
You want to hear it today?
No.
Your question is it a slope? But it's not 48. Is it constant? Okay. Guys, a lot of y'all are forgetting the very basics. Most of us do not even remotely have written down the very first thing I told you to write down yesterday. What is the very first thing you have to do?
Write down the equation.
Yeah, so to figure out what function it is, what type of function it is. I see a lot of tables written, and I see some other things there, but I don't see a lot of us noting what type of function it is. Write that information down. What type of function do we have here?
Linear.
Linear, because as soon as you identify it's linear, what should that tell you to do?
Write down the linear function.
Write down the equation of a line, right? Notice I didn't give you an exponential today because I need you to think. I'm going to mix these things up. You should note, hey, it's linear. Because it's linear, what equation? Y equals mx plus b. So I need what? I need slope and y-intercept. And I'm going to go ahead and tell you this. All y'all that are saying minus 4, you're wrong. Because you're, again, not taking the time to write out what is the equation for slope. Is y equals mx plus b just slope?
No.
Remember, that's slope intercept form of a line. Guys, y'all got to remember, and this is why you need to think through, and the language is important. So y'all have m for slope and b for y-intercept. That's slope-intercept form. I need slope. I need just m.
Rise divided by y.
Okay, rise divided by run, which is primarily referring to what mathematical representation?
Division.
Representation.
Graphical.
Tables and algebraic.
Tabular, algebraic, graphical. Rise divided by run is what?
Graphical.
Graphical. I don't have that right now. What's another way to write slope? Because I could create a graph, but that's more work than it needs to be. Come on, what's another way to write that?
The triangle.
The triangle, which means,
Delta.
well, it is the Greek letter delta, but it just means change. Change in. If I'm rising, which variable is rising?
Y.
Change in y. Divided by?
X. Change the X. Triangle X.
Yep.
Change the X.
Change in. All of y'all that put minus 4, that is only what part of the slope?
Change in Y.
That's only the change in y. What's the change in x?
Adding to the last one.
No, but the last one.
The last one.
Whoops, I messed up. That's supposed to be a 3.
Okay.
I was confused. That's
That's
you
my
got
bad.
confused with that.
So m equals?
That's why.
3.
Negative 4 divided by 2.
I mean 2.
Which is negative 2.
I was confused.
Yeah, that's my bad. You should have called me out on that one. I make mistakes. But the main thing I need you to focus on and note is if I'm looking at slope, it's not just the change in y. You just do the change in y, you're going to mess yourself up. But we're still not following that blueprint of if I'm going to write the equation of a line, or if I'm going to write an equation, I need to know the type of function. Because the type of function defines the equation that I should use. The equation, then I know, okay, I need slope, change in y divided by change in x. A lot of us are jumping to that table and just looking at the y, which tells us part of it. But if you wrote out m equals change in y divided by change in x, it helps get you there more effectively. Yes, sir?
So what would make that table, say like exponential or quadratic?
Well, if it's exponential, what should we be looking for? Like yesterday,
Constant multiplicative.
constant multiplicative.
And then linear is
Yeah.
additive or?
Well, linear has constant additive if it's quadratic. So here's an example of a quadratic. Okay, so negative 2 squared is 4, negative 1 squared is 1. Note it's minus 3, minus 1, plus 1, plus 3. That's not constant additive, is it? No, but if I look further, I go plus 2 each time. That's constant additive. And what type of function has a constant additive rate of change?
Linear.
Linear, which means that this rate of change, remember, the very first column is always, or first set of differences, is your rate of change, right? So because this is constant additive, this rate of change here is linear additive rate of change. Because it has a linear additive rate of change, it is quadratic. So remember, the rate of change defines what type of function it is. A quadratic has a linear additive rate of change. If that's something you're not familiar with, what should most of us go to and study to get that information down?
The video.
You can go to the video, but which set of notes did we clearly define that on? That Venn diagram, guys. Remember, that Venn diagram is a single page summary of everything linear, exponential, and quadratic. That Venn diagram. And if you weren't here for the Venn diagram, then maybe go watch the videos, right? To get those notes or come to tutoring, whatever, right? I've got a lot of options for you. Tutoring is the most effective, but if you can't make it to tutoring, the videos are there. But you've got to know that a quadratic function has a linear additive rate of change, which we can identify that once we get to constant additive. Okay, so I've got y equals, m is now negative 2, x plus, what is b again? The y-intercept. What is that?
Negative 4.
No, I believe it.
I thought negative 4 was the change in y, wasn't it?
Yeah.
Okay.
It'll be, believe it or not. Yes, we do.
I mean, it has one. Did I give it to you?
Seven.
How'd you get 7?
Because it's jumping by 2, so.
So y-intercept exists when the input is
0.
0. That 0 would be right here. Right? If every 2 is negative 4, every 1 would just be minus 2.
True.
That's my minus 4 right there. Okay, so plus 7.
Good job. That makes sense.
That makes sense.
Did you know there's an easier way to do this one though? Kai, what's that easier way?
Just substitute for the source.
There's another equation called the,
You talking about the linear function?
Point slope.
isn't there a point slope form as well?
Mm-hmm.
Yeah? What is that point slope?
Isn't that the y1, x1 minus x2 times y2 or whatever?
You're thinking that's a sloped formula, but instead of doing this, right, if you're finding the difference between your y's and your x's, that's just the change in y divided by the change in x. That's just an easier way to write that and remember that. But the point slope, y equals
Young parentheses.
m parentheses
X minus X one parentheses plus 1. I mean Y1. Yeah.
right? Where x1 and y1 are an equation. I meant to bring this up yesterday, and I realized during third block I didn't show this to you. But this should look familiar, or look similar to this equation.
Isn't that the vertex form?
Isn't that the vertex form of a quadratic function?
Yeah.
Notice how h, k together, what was that point?
That's the x and y of the vertex.
That's the x and y values of the vertex, right? Notice x1 and y1 is just any point on that line, right? And we don't have an a, because remember that's defining the concavity, but we have a slope instead, right? So they're connected. Gabby, headphones please. Okay. So if you can remember vertex form, that's going to help you remember point slope form. And point slope would be easier in this case, because it doesn't matter what point I choose. My slope is still negative 2, parentheses what point should I use?
-3.
Negative 3, 13?
Yeah.
So that'd be x, and then what?
That's minus
Plus
3.
Minus negative 3, which would become
Plus 3.
plus 3. Now I want to pause and I want to point this out because some of us were freaking out about this yesterday with that vertex form. Remember, it's subtracting, right? So to get a plus, I had to have a negative x, right? Minus a negative is how I get a positive there. It's always the opposite of whatever's inside of those parentheses with the x. But then plus, what's y1?
13.
13. And if I simplify this, right, you don't have to. You could stop there. But that'd be negative 2x minus 6 plus 13. And what's negative 6 plus 13?
7.
Right. Doesn't that give me the same exact equation?
Right.
Okay. So that's something you want to be aware of. I personally, yeah, if I have the y-intercept, I'm going to go with slope-intercept. But if I don't have the y-intercept, I'm just going to do point slope. But it's important to identify what first.
The slope.
The type of function. I don't necessarily have the slope, right? I need to start with what type of function it is. Because once I know the type of function, I can write out the equation, right? And so be careful. I did see some of us who did a great job of writing out an equation first, but we didn't slow down to take into account what type of function it is. The type of function defines the equation. Then the equation defines what I should be looking for. If I see m there, I'm going to write out the equations for m. Either rise divided by run or the change in y divided by the change in x. And then if I have a y-intercept, cool, I'm going to do y equals mx plus b. If I don't have a y-intercept, I'm going to do point slope. What are your questions at that point, at this point? Okay. I know it needs some more practice. Please hear me very clearly on this. Your practice with these things, instead of just spending hours or an hour and a half just purely practicing, the practice is going to come with these bell ringers. But I need y'all to get seated and get to work right away. Get out your notes. Collaborate within your groups if you need to. Please understand, learning, like the assessments, that's an individual thing. That's where you show what you have learned. But learning as a whole is a collaborative thing. Learning happens with discourse, with talking, with making sense out of things. So during small group time, during bell ringers, talk, figure it out together, help each other learn it better. And then we have to spend less time here, and I'll be around to support you. But take advantage of the time that you have. All right, what are your questions before we get back to Desmos today? Okay, so for those who missed yesterday, we're going to do a very quick overview of what we talked about. So we're going to get back to the Desmos activity, forms of quadratic equations. And then we're going to look at Module 1, Topic 1, Lesson 4. You will want your calculators at that point. You don't need to be logged in though. So remember, this is very, very, very true today. What is mathematics?
Study of patterns and relationships.
Study of patterns and relationships. Please note that, because all that we're doing in Desmos, you don't need me to directly lecture to you at first. We're looking for patterns and relationships and keeping our hands to ourselves, right, Elijah?
Huh?
What?
What?
Keeping our hands to ourselves?
Right.
Yeah, I know. Okay. So the study of patterns and relationships, we're looking for patterns and relationships as we manipulate the sliders in Desmos, right? So just pulling Desmos up really quickly. This is what we got to yesterday. And so when we were here, right, we were adjusting the value of A. And what is the big thing we wanted to note when we were adjusting the value of A?
If it affects the
Okay,
content.
This is slide 11, okay? But as I changed A, both in standard form and in vertex form, A was changing the what?
Concavity.
Concavity, right? That's a pattern that we noticed. And then I worked and helped you work on the language. Especially because we also noted, hey, as A gets further from 0, a lot of us originally thought that the graph was getting what? Skinnier, right? But what did we actually talk about?
Slimmer.
It's stretching out.
It's stretching in which direction? Vertically, right? Because remember, and I talked about it, if you take Laffy Taffy and you stretch it vertically, what's it also going to do? Get skinnier and stickier. But we're going to stretch it vertically, which is what kind of makes it look skinnier. And so we need to be aware that the A is stretching it vertically and compressing it vertically. We also noticed here with the standard form, what is C controlling?
The Y value, yeah.
There's a lot of Y values. Which Y value?
The
Y-intercept.
The Y value of the intercept.
The Y value, the Y-intercept. Note right now, C is what?
Negative 2.5.
Negative 2.5. What is the Y value of the Y-intercept?
Negative 2.5.
Negative 2.5. So that value of C is defining the Y-intercept. And so we took notes on this yesterday, right? Oh yeah, so don't forget, please hear me very clearly. You are going to have to know the equations. There's no way around it. You got to know the vertex form of a quadratic equation. You got to know.
Students, please pardon the interruption. I need to see the following students at the front desk now. The reason I'm making the announcement is that we will not have any further announcements until the ASVAB is completed. But these students need to come to the front office. Alexis Brown, Stewart, sorry about that. Trinity Matthews, Demarion Wilkerson, Eliza Coleman, Janiah Hines, and Jayla Taylor. Thank you.
You have to know the three forms. Like, you have to know what the equations are. Just like, and I'm going to tell you, you need to know the two main equations of a line, the slope-intercept and the point-slope forms of a line. You need to know what those symbols mean. You need to know the standard exponential equation and the equation for when you just have a point and not a y-intercept. Please hear me very clearly on this. If you need to, make flashcards, make a Quizlet, make whatever, because you need to be able to look at the equation and recognize the different aspects of it. Because yes, you need to be able to look at a table and write the equation, but you also need to be able to look at the equation and know what those different pieces mean. For instance, right, y equals 3 times 2 to the x. As soon as I see that equation, do you know what I know about that function?
It's exponential.
It's exponential, but what else? Those numbers mean
It
something.
has a constant, it's constant at, well, yeah.
Well, constant multiplicative rate of change. Okay, what is that constant multiplicative rate of change?
2.
Alright, that's what I would want to note. Okay, this is y equals a times b to the x, so I know my rate of change is 2. What else would I know about that equation? What is that 3? The y-intercept. So I know I've got 0, 3, and I'm repeatedly multiplying by 2. So then I can fill out a table, and I can make an equation or a graph from that table. So you have to know the equations, you got to know what they mean. Because if you know what the different parts of that equation mean in both directions, you're going to know the mathematics. And I know that for some teachers, it's kind of gone out of fashion and style to know equations, but I guarantee you this, you go to any higher level math class, you're going to have to know what that equation is. So take the time, put in the effort, study those equations, and know what the pieces mean. You have all the notes, where?
In our book.
In the book, but where else? That Venn diagram. Because remember, the linear and exponential wasn't in the wasn't on Desmos, right?
It's not the equation.
Yeah, but that's on the Venn diagram, right? You've got to know these things. You have to. But then also we have the 3 forms of quadratic equations as well. And so you've got to know those 3 equations that we've been studying. All right, so once again, really quickly, we just talked about it. What's the main part of A in this vertex form? It doesn't translate. A is defining the concavity. When A is positive, the parabola is going to be concave up. And when A is negative, the parabola is going to be concave down. Okay. And then again, we just talked about it. It vertically stretches and compresses. H and K, what's that defining? It's not, be careful, it's not y-intercept. What were you saying, Max?
H translates the parabola horizontally.
Okay, so H will translate the entire parabola horizontally. So K translates the entire parabola vertically, but also H and K define what important points?
Vertex.
The vertex, the x and y of the vertex, right? Okay? So be aware of that. The h and the k define that vertex. Then we got to the standard form. Did anything change with a?
No.
Nope. A still defined the concavity. It's still vertically stretched and compressed. But then we already talked about this a little bit earlier. What was the value of C?
The y value of the y-intercept.
Right? So the y-intercept will always be 0, comma, C. 0, comma, C will always be the y-intercept. So if you have the standard form, you know the y-intercept. Now there was the one tricky part, and I remember I told you this yesterday, that it is almost impossible to just discover this on your own. But what was x equals negative b divided by 2a? That was the...
Substitute to get the y.
Well, you would substitute that in to get the y value of the...
Line of symmetry.
So remember, this is the x value of the vertex. If you take the opposite of b and divide it by 2a, that always gives you the x value of the vertex. And you would have to substitute it into the equation to get the y value. Right? So that's a good point. Alright, so if all that sounds like a foreign language because you weren't here yet, or you weren't here to say stop stressing, because it should sound like a foreign language because you weren't here when we spent an hour and a half on it, an hour on it. If it still sounds like a foreign language and you were here yesterday, let me know and we'll talk about it some more at some point. We'll get practice with these things. Make sure you have it in your notes because we're going to look at an entire lesson out of the book where we're practicing and applying these ideas. Okay? And so we did this. So here we are today with the factored form of a quadratic equation. What did we discuss yesterday about A?
It's the same.
It's the same thing. Please note, what is the only letter that has been used in every single equation? A. There's a reason for that. Because A is the same in every equation. It defines the concavity. If A is positive, that parabola is going to be concave up. And if A is negative, the parabola is concave down. Right? The further A gets from 0, the further it vertically stretches. The closer it is to 0, it vertically compresses. Is the term. I forgot to talk about that in here. Yes, sir.
I want to pick with you. Why somebody put a name on it on the wall?
Does that look like my handwriting?
I know, but you let him put it up here.
It's a chalkboard wall. All of you can write on it.
When? I want
Anytime you want. You can do any work you want up there. I've told y'all that. Y'all choose on to. The very first week of school, I
That was like a
emphasized
month
that.
ago.
I'm gonna put my name up there.
Y'all chose not to
I
use it a month ago.
ago.
You can do it if you want to come in during enrichment. No, hold on, I'm teaching right now. If you want to come in during enrichment, you can draw on it. Like I did the chalkboard wall so that y'all can use it. I think it's fun, but y'all haven't taken advantage of it. That's not my fault. Okay, really quickly, I do want to go back and point this out. Here's one thing that I forgot to talk about yesterday. I know some of y'all noted this, but when A was 0, what did we get?
A line.
A line. And I meant to talk about this. You don't have to write these notes down, but I do want you to note that if A is 0, you're right, we're getting a line. And here is why. Let's let A be 0 times x squared plus bx plus c. What's 0 times x squared?
0.
That's a 0. So what am I left with?
A line.
X squared.
Y.
I mean,
Y is
0. Bx plus c.
Right? We don't even have to write the 0 there. What is that the same as?
Slope intercept.
Yeah.
Isn't that slope intercept? Y equals mx plus b?
Yeah.
Remember, these are just letters to represent things. The major thing to remember is that this multiplication is repeated addition, and that's a y-intercept. If A is 0, you are in fact left with a line. Because you no longer have x squared. What is the defining characteristic of a quadratic in an algebraic representation? The x squared. That x squared is what makes it quadratic. You don't have the x squared, you don't have a quadratic. And so if A is 0, we're left with a line.
Miss Esther already told me that.
Man, this Esther was better than me yesterday.
Yes, way better.
Oh.
JK.
It's okay. I don't harbor any ill will towards you.
Yeah, right.
See that class.
Too slatty for
What did
that.
you say?
He too slimy for that.
Alright, so, sorry, just joking. Alright, when I look here again, this is now what form are we on?
Factor form.
We're on factored form. This is slide 14 on Desmos, okay? And just, I want to quickly verify once again, right now, A, positive or negative?
Positive.
What?
Negative.
Mine say
I'm on
negative.
B.
I'm talking about mine up here.
Oh.
I'm over here tripping out.
A, my bad, A right now is negative, which makes sense because the
Concave
parabola
down.
is concave down.
Right.
When A is positive, it's concave up. And we can see as A gets further from 0, is it vertically stretching?
Yes.
Yes, very much so. Okay, so we are through with A. Remember, I told y'all yesterday, make your life easy. Under A, instead of rewriting it again, I just said, hey, see the notes about A under vertex form, right? So what we now need to do is move to slide 16. What are you supposed to be a, yes sir?
Oh, what's the code to the Desmos?
I'll put it up there in a second. Hold
I
on.
was just
You're
talking.
Yeah, I got you. Hold on. Let me get the directions out there and then I'll put the code back up. So, what are we adjusting now in slide 16?
R1
A and the factor form. No,
R1,
R1 and R2.
Slide 16. We're looking at R1 and R2. Slide 16. Isn't this 16?
No, you said 14 first time.
No, you said 16. He said 16. Yeah.
Thank you.
No, you
Oh.
told me 14.
Hold on, I did just look at 14.
That's the
It's-
same equation.
Chill. I meant to take out the value of A right here. We're supposed to be focusing on the second question where it says, how do the values of R1 and R2 explicitly connect to the graph? So look at R1 and R2, look for a pattern, right? So that's my bad, Emma. I forgot that. I don't know why I didn't take out that part about A. We already did that part. We're focusing on R1 and R2 right now. So manipulate R1 and R2 on the sliders. Try to find a pattern. Where do we see R1 and R2 on the graph? All right. Go ahead and get to work on that. Put your observations down on your sheet of paper. Make sure you talk about it with your group. And there's the code, the top one. The H8.
I please do
R1 moves the left side. The right side. And R2 moves the left side.
Oh, it's already right there, please.
Isn't that right?
It's
R1.
changing. I don't know what point.
Before you ask me, have you talked to all of the other 3 people in your
I just
group?
told him what I thought it was.
Right.
Okay, but hold on a second. Hold on. Remember, you're supposed to be having a discussion. Don't tell them. It's hard to have a conversation with someone who's telling you
Why are
something.
you
But,
at me?
okay, what do you think is happening? Or do you see this pattern as well? Ask it as a question and engage in a discussion. Don't just tell.
A little bit of equal.
It changes right.
2 lines or 2 points? Does anyone know what those 2 points might be called? Let me point this out. You see that red point?
I tried.
The vert.
What is that?
Those colors.
First of all, it's not one.
Well, no, my question is, what is that red point?
The wires. No, I got
Why do we know that the red point's a wire set? Well, it's not. Right, it's where the function intersects y-axis, right? Does anyone know what those two other points might be called? Is it where it's intersecting the x-axis? I don't think so. So mathematicians are not original, right? Like, oh, we're intersecting the y-axis. Why intersect? Oh, we're intersecting the x-axis, right? It's an x-axis. But like, it's beautiful because it makes our job easier, right? Like, oh, it's so lame. Do you really need it to be more complicated? Do you need math to be more complicated?
We're not even gonna need.
I think that's why they go.
Hey, you have this whole like exploration and critical thinking thing where we sense out of patterns and relationships. Boom, gotcha. Alright, moving on. Key Anthony, what group you in? Then turn around and look at your group and talk with them.
Yeah, I told him.
But don't talk to these groups.
Sorry. We already figured it out.
But what are R1 and R2 doing? That's what we need to
Well, I was
focus
saying
on.
that R1 was, R1 translates to X value.
value? What x value? Let's be more clear with that language.
Wait, what do you mean, what x value?
What x value?
Because.
How do I say that?
I don't know. What x value?
What ain't
I got a question.
I might have an issue with it.
When you said what x value?
Yeah. Well, I mean, there's infinitely many x values.
Because there's like.
What we looking at is only
The line?
tell me stay right here.
Okay, what's your
So
point?
that's what you think.
Two of
You know?
these points. Anyway.
Thank you.
This must
Thank
be
you.
an us discussion.
It is, but I'm going to clarify something. I need y'all to hear me on this because I think that this is a misunderstanding that most students have. How many x values are there for this parabola?
Two.
You sure about that?
No.
Didn't you
Who's
say
just
infinitely?
saying four? Oh, four.
There's infinitely many x values. Pause and listen. Because we need to be clear with our language. Right here, you see this point? That's a point that's on the curve. That's why there's a curve there. That point right there is 2, 5. Is there an x value for that point?
Yeah, two.
Okay.
But
So right here, is there a point right there?
Right now.
So is there an x value for that point?
Yeah.
It's like 3.
Is there a point right here?
Yeah.
What about here?
Yeah.
Here?
Everywhere.
so you weren't referring to the only point that were graph.
So, well, here's the thing, and this is why we need to be clear with our language. If you say the x value, you could be talking about any point. So when you say the x value, unless you're more clear than that, there are infinitely many x values for the different points. When y'all were talking about x values, what were you probably actually talking
The
about?
x values that are actually graph.
I mean, that's actually graph. Like, here's what you need. So the points on the x-axis called the what? X-intercepts.
That's what I thought you said. That's what I said too.
But I need you, and that's why I said we need to be careful with that language. That language matters. And so I need y'all to hear me on this. And Anthony brings up a good point. That's a misunderstanding for a lot of students. So I'm really glad he said this. Guys, this point is actually graphed. You know what you get when you have infinitely many points connected together? A line or a curve. Not necessarily just a parabola. But when we create that curve, technically a point has 0 sides to it, and so when we connect infinitely many of them, that's what's creating the curve. So that point is graphed, it's just not, we're making it bigger to make it easier to see. There are, like everywhere along here is a point. That's why we have a curve. And that's why we have to be careful with our language, because that's a misunderstanding. And if you don't understand that, these curves actually matter how accurate we are with them. They mean something. Okay? So, I think I'm starting to already get into that conversation that most of us are starting to know that R1 and R2 are defining the what?
X-intercept.
The x-intercepts. Right now, my R1 is -3, and one of my x-intercepts is -3, comma 0. R2 right now is 1, and what's one of my x-intercepts? Okay. Notice, and I need you to know, this is why it's important for me to hear your conversations. I needed to know how much of that language we understood. Like, that was a pattern in a relationship that a lot of y'all noticed very quickly. And I do want to point this out. Yesterday, if I had started you with this function, would you have noticed that R1 and R2 are the x-intercepts right away?
Yes. I would have.
Y'all didn't notice,
seen it.
hold on. Y'all, but my point is, I know that y'all didn't notice H and K were the vertex right away.
Oh, yeah, true.
Y'all didn't notice right away that the y-intercept was the y-intercept in standard form. And Alasia brought up a good point. I'm never going to need this. I get that. But do you see how you were able to start thinking more mathematically the further you got into this lesson? I didn't have to tell y'all R1 and R2 are the x-intercepts. Y'all jumped there. You noticed that right away. Critical thinking, noticing of patterns and relationships, that is a skill that is going to be helpful for the rest of your life. That's why I teach the way I do. Okay? Some of us will need to know factored form gives us our x-intercepts. If you're looking at any of the hard sciences, engineering, mathematics to study in college, you will need that information. Okay? But if you're not, patterns and relationships like this, learning to think mathematically and logically, develop arguments and be precise with your language, those are skills that will always be useful. Okay? And so, not to get on my soapbox and preach about all those things, but looking here at values of R1 and R2, right? What are those defining? R1 and R2 define the what?
X-intercepts.
All right. Now, we need to be a little bit more clear which part of the x-intercept. the x values of the x-intercepts. Notice how it don't just say x values. Because how many x values are there for that parabola?
Infinite.
Infinitely many. Because there's infinitely many points. But R1 and R2 define the x values of the x-intercepts. Note that's R1, comma, what is the y value for every x-intercept? 0. An x-intercept exists because it's on the x-axis, and every point on the x-axis has a y value of 0. Are there any details that I've just said that I need to clarify?
X values of the X integer, can you explain that?
Intercept.
Oh, no.
So that's just shorthand. That's an x-intercept. When I do x-int, it's an x-intercept. Do I need to clarify what I mean by an x-intercept?
No, sir.
No, no.
And then we're just crosses the X line or Y line.
X-axis.
That's what I was
X-axis.
asking.
Axis, that's what
Yeah,
it's
yeah,
called,
yeah.
dude.
So an x-intercept is where the function, so be careful, don't just say it, the function intersects the x-axis. An x-intercept is where the function intersects the x-axis. Yeah. Yes, Max?
Doesn't it just do the opposite of C in the standard form?
So when you say the opposite, what do you mean by that?
Because C is the y value of the y-intercept.
Right, okay, that's what I wanted to understand if you were meaning. So when we looked at the standard form here, right, wasn't 0 comma C the y-intercept?
Yeah.
Note, with a y-intercept, the x value is 0. With an x-intercept, the y value is 0. And if that is a thing that's making you struggle to remember, it made me struggle to remember that for a long time, even through most of high school, until I realized what again is a y-intercept? It's where the function intersects the
Y-axis.
y-axis. So if I'm looking right here, notice how the y-axis is in between an x value of -1 and an x value of 1. Hey, what number is in between -1 and 1? 0. So everything on the y-axis has an x value of 0. If I'm looking at a point on the x-axis that's in between the y value of -1 and 1, again, what's in between -1 and 1?
0.
0. So every point on the x-axis has a y value of 0. Right? That's always going to be true. And it was by pairing it visually with that coordinate grid that I started to make sense out of it. And I no longer had to memorize it. I was like, this makes sense. So please understand, right? I've learned a lot. I didn't just know these things immediately. There was things that I had to discover and notice to make it easier. It was learning how to think mathematically that changed a lot. One thing I do want to point out, because this is something we need to be careful about. I'm going to compare it to here. When we looked at the vertex form, whatever value k was, wasn't that the value of k when we did the vertex? But what do we have to do here with h?
Create a minus it for x.
Well, yes, but that means that we needed the opposite sign, right?
Oh yeah, positive.
So the h was actually positive in this situation. So look right here with this factored form. What are we going to need?
A positive R1, a positive R2.
Well, not necessarily always a positive. We need the inverse. Or the opposite, right. So like if I had, let's look at the practice problems, right? When I look here at y equals 2 times x minus 3 times x plus 7, remember that's a times x minus r1 times x minus r2. So what is r1 for this first factor?
3, positive 3.
Positive 3, so the x-intercept would be 3 comma 0. See how I needed the opposite sign of what was inside of parentheses?
So when
Right.
you're looking for the x-intercept, you just look at the opposite of whatever is inside the parentheses.
Yes, the opposite of it. And then for the other x-intercept, it would be
-8.
-7.
-7, the opposite,
Oh, snap.
comma 0.
No, that's not dumb, dude.
Okay,
I be chilling out sometimes.
alright.
But my dad don't
And so what would be the concavity of this equation?
Oh,
Concave up.
Okay, that's like that.
I'm not gonna spend long here because we do need to get moving.
Didn't we already do that? We gotta write it down.
We did.
This is the very last
the
one.
last one.
We gotta write it down.
Like, we trim on July.
I mean, factored form is new, isn't it?
We trim on so bad.
We've done vertex form, we've done standard form, but we didn't do the practice problems for factored form. Now, I want to pause and I do want to point this out, because this is going to help you understand why it's the opposite a little bit. Remember, for an x-intercept, what do we know about the y value?
0.
So I can substitute 0 into this equation. We're going to go into a lot more detail about this later, so you don't need to stress about it right now. But I want to point this out. In order for this expression to equal 0, what do I have to be multiplying by?
0.
This is known as the zero product property. It's foundational to a lot of what we'll do with polynomials. In order for this product to be 0, at least one of those factors has to equal 0. What would I do from here to solve those equations?
Minus
The first
7.
one? No, that's the second one.
I know, but do you see how that gives me the opposite? What would I do to solve this equation? Plus 3. Do you see how that gives me the opposite? Okay? So I want you to notice, right, that we're going to get the opposite because of the idea of the zero product property instead of equals 0. You don't have to know that yet. We'll go into more detail about that in the future, but that is a good thing to be aware of. It gives a little bit more background to that detail. Go ahead and finish out that table. We'll come back together in just a couple minutes.
Okay, so for the last.
Say again. Huh? Yeah.
It's fine. I can take a picture.
Huh?
It's right there.
Huh? So what has always defined concavity up to this point? Positive or negative for the what? A, right? Do we still have an A in this equation? So it's still based on the concavity,
Oh, wait.
right? Value of A, remember it's A times x minus R1 times x minus
So
R2.
what number the second one is
Well, we
called?
just finished that top one, right? Right, so that 2 is our A. Because A is positive, it's concave up. Okay. Yes.
For the last one, since you only got like one set of,
Have you talked to your group yet? Talk to your group first.
almost.
No. Mr. Kenny, I don't wanna.
Okay, you got it, okay.
Hey, guys.
Oh, yeah, what else we got? I was saying.
Mr. Kenny said, I can't tell you this.
Yeah, so just do it's fine.
Just like I said, we don't know.
I need like
I get the big one.
Yeah, wait.
Let me cut you off. I cut you off.
What's the Lulu?
Stop.
Bro, Jason went.
Little bit white coats.
Cool in the world.
Little bit white coats.
Yeah,
There you go. That's what she's trying to say.
please take it.
Alright, what questions do you need to ask?
Ah, you remember.
Well, you wouldn't answer my question, so it doesn't matter.
Stop.
But it does.
It comes from the square, though.
So,
Do I got
what comes from the square?
Third.
So if we look at number 3 or number 4?
The 4.
The last one?
Yeah.
So notice we have h of x equals 5/4 x minus 3 squared. What does it mean to square something?
Repeated addition.
It's
I mean, multiplication. I'm
So-
sorry. Repeated. Because we keep saying it.
So there's 2 different ways to interpret this.
Yeah.
it's important to notice that that's x minus 3 times x minus 3. Now, do I really need to write that x-intercept twice? I could have just written it one time. We're going to talk about something called multiplicity later. But what this really means is that I just have one x-intercept.
How is the fourth one concave down?
Right.
Yeah, how is it concave
Because
down?
I'm not paying attention. Thank you.
Good job, Mexican.
Okay? Concave up. Alright. What I want to focus on really quickly is this. Does this equation look like any other form?
Yeah, a little bit, no. Wait.
Is exponential a different form or is that a different function? So pause really quickly, guys. Hey, is a quadratic ever going to look like an exponential?
No.
Those are different functions, so they would look different.
No, never mind. No, I don't. I have a slope in it.
Does that remind us of vertex form?
No.
If I put a +0, does it now?
Yeah.
Sometime, got it.
Okay.
I like
Notice where's the vertex? 3, 0, which is also the same as the only x-intercept that we have. If I were to graph this, it would look something like this, with an x-intercept and vertex at 3, 0. That's not perfect, but it's supposed to be right there. Okay? And so that's what's happening. That's why there's only one x-intercept, is because that's the vertex on the x-axis.
Right.
Okay?
I need it.
What are your questions?
I think we're doing great. I think I just want to go to
Yeah, when you miss yesterday was a big day to miss, unfortunately. Okay?
How about you guys?
Fun for me.
Yeah, sorry.
You know what I said, I had 80, 90 here? I lied.
What's you got?
A 90.
I got like a whole page on the
What
phone.
you-
You did 4.
I didn't know.
I said that.
Oh.
I got my grades mixed up.
Who you got?
Go ahead and go, if you have the iPad, stop it. If you have an iPad, go to the very last page. If you've signed in, just do a quick drag the point to show how today went or how this lesson went. So how well did you understand this math today? How did you feel about the learning math? If you need to put any clarifiers or explanations on there. I know for some of us today was our very first day with this, and so I imagine it would be tougher.
Can I write mine on paper?
If you really want to, sure.
Mine is my iPad.
Charge your iPad.
The charge, the iPad is slow, I'm telling you.
Overnight,
I need it for my phone.
I can always find excuses, but yeah.
Should I put down each slate before I'm more like?
Yeah, for sure. I definitely think that's something fair for most people. We're not used to studying equations and really making sure we notice them. And please know how I use that term study. I never said memorize. Stuff you memorize, you're going to forget. You got to study and know them. Don't memorize them. Study and know them.
I'm definitely coming to tutoring.
Wait.
Yeah. Next week will be a more standard week. Well, the rest of the weeks will be more standard. Just this week was bonkers with different responsibilities I
Are we
have.
going to the book now?
To me.
Huh?
Are we going to the book now?
Yeah, we are going to the book. Module 1, Topic 1, Lesson
So
4.
we don't need the iPad anymore?
No, yeah, you can put your iPads up.
GBI. G.
Well, not every lesson can be off of Desmos, but you should keep your notes out because we will use them in this lesson. You will want page M1-51 from the book.
Okay, what we doing?
Brantley, good on taking those notes? You will probably still want to come into tutoring or watch the video to make sense of it. And you can also go on to Desmos and play around with it to make sense out of things as well.
I was
You
just
just
being
got a
honest.
negative
To
attitude.
my
I was
bad.
being honest. I did being honest.
So, we should have our books out. M1-51 is where we should be looking right now.
You said
Couldn't
M1,
wake up earlier?
I mean M1.
I do wake up early. All right, but what?
M1-51. Okay,
Do we need to keep this out, the second page?
that's actually going to be something we're doing within this lesson. So that's a good point. There is a second page that I gave out yesterday. I'm still debating whether I'm going to do it, but hold on to it for just a second. It's just time.
I didn't forget about our strawberries.
Oh yeah, I have those hidden somewhere in the room. I gotta find them.
Can we play that, Dusty?
Alright, so this lesson 4 is called True to Form, and it's all about forms of quadratic functions. And so notice we got our key terms: standard form of a quadratic, factored form of a quadratic, and vertex form, and concavity. Whew. And so we have these learning goals, but really it's focused on what we've already talked about, right? Right now, we want to analyze the forms of quadratic equations and identify the features of a parabola based on the form of a quadratic equation. That's what we just did. We took time to figure out what features we could recognize based on the equation right away. And so we're going to skip, not necessarily skip, I'm going to just talk through this quickly because this getting started is just going to slow us down. So if you have a single point, how many lines can you draw through that point?
One. You can draw infinity.
No, you can draw
I would say I could draw one here, I could draw one there,
So
here. There are infinitely many points through one line.
Right.
Or there's infinitely many lines through one point, is what I should have said.
Okay.
But what if you have 2 points?
Oh, I
Infinite,
forgot.
right?
No.
Infinite, right? Independent.
It'd still be infinitely, right?
Alright, can anybody come draw a different line?
I want to draw one.
Couldn't those 2 points be on different
drawing
I
the
lines?
second
know
one.
what you're doing.
I'm
do
drawing
know
the
what
second
you're
one.
doing. You gotta go through both the points, huh?
It's gotta go through both the points.
Okay, then you can be one, right?
Is there any other line that I could draw through both those points?
A concavial.
A line.
Well, you're talking about a
You can't
parabola,
do
aren't you?
Yeah.
I'm only looking at a line.
No.
So if you have 2 points, how many lines can you draw through them?
One.
Just one.
You got up for no reason.
So the
No,
points,
that's good.
Everybody
so
said
points aren't from different lines? So
Say, hold on, one second.
points couldn't be from 2 different lines?
Well, the question is, how many lines can you draw through both points?
Oh, okay.
Right? How do you go through both points? Here with the C, how many lines can you draw through all points A, B, and C?
None.
Wouldn't
I
that,
got you.
wouldn't that
None.
So you can go there and draw a
Oh,
triangle.
none.
Oh, never mind.
Right, none.
What if?
You can't do that. That's
Wait.
no line.
Dude, why should she finna try to sit there and figure it out and like, you know,
You
good
can't do
drawing.
it.
There's 53.
Let's try it.
Bruh, I'll tell you.
Oh, my mama, she trying.
You can't do that.
Okay.
None. Zero.
Right.
So,
Is
is
that-
that a single line?
No.
No,
So-
that's two.
Listen, hold on. What defines a line?
One. I mean, a straight,
It has to be straight, doesn't it?
180 degrees line.
That's
It's a no
never
function.
ending.
Huh?
Never ending.
You're already forgetting the very first thing we talked about with what defines a line.
A linear.
Slow?
A slope.
Oh,
And a slope is a what?
Rise
Constant
divided by rate.
constant
additive rate of change.
Rate of change.
If we're creating this angle in there, is that a constant additive rate of change?
No.
I knew she was gonna get it in a
So-
triangle.
It would be 2 lines, right? It could be, or be called an absolute value function or a piecewise function. But the real answer is, you can't do 1 line through 3 points.
You can't do an awkward parabola?
But the question is a line, right?
Oh.
So it'd be
So that's good thinking, and I like the thinking, but we gotta follow the directions for this one. We only want a line. And this is a careful thing we need to be careful about. A parabola is not a line, it's a curve, right? And so we need to be careful with that language, right? The language matters. Attention to that language matters for sure. So, what is the minimum number of points you need to draw a unique line? You have to have 2. Okay? Whereas, if we're to talk about parabolas starting at number 3,
Can I go and draw it?
I bet we could do like 4.
just 4,
Personally, that's it.
there's 1,
Infinite.
Like
there's 1, there's 1,
Damn, I'm gonna do
and then here's 1,
Infinite.
and here's 1,
Not infinite.
and that's even just the vertices, right? I could draw 1 here that goes through that point. I could draw 1 here that goes through that point.
Draw one sideways.
Come
That
on,
would
dude,
be
they were a lead.
We're not going to do one sideways. It is a parabola, but it's not a function. And we'll talk more about that. But so how many parabolas can go through 1 point?
Infinite.
Infinitely many. Okay.
That's crazy.
How many parabolas can you draw through 2 points?
You can do 2.
Well, there's 1.
Couldn't that be also a
Infinite.
lot?
You can
It also could be a lot. Here's 2.
I don't know if it's infinite.
Here's another 1.
Like, you're a Miami Dolphins fan? Like, what's going on?
I just got those colors in my hand. So how many do you think it is?
The dolphin.
At least, I'm a
Me.
Dolphin fan. Don't-
Four.
I mean,
too loud. Kyle, you're a Miami Dolphin fan.
It could be infinite, right?
it's infinitely many again.
Oh, okay.
If you only have 2 points, you would have infinitely many possibilities for a parabola.
Would it be the same with C?
No,
No.
I disagree.
Emma tripping.
So if you have 3 points,
Look, Emma, my mom.
it will be only 1 parabola.
So,
And even that's not perfect, but to hit all 3 points, it would only 1 parabola is possible. Okay. So that's something we want to note, and we're going to use later. How many points define a parabola? 3. 3 points would define a parabola. The only time that's not, you don't have to have 3 points is when you're working with the vertex. Otherwise, you need 3 points. What? And so just because the vertex is a special point, we'll use that once and we'll make it work. Okay. So it's just making those connections. That's not going to be something I test you on, but it is something that is going to help you moving forward. We're going to skip this number 1 here. Anyone know why? It says the form of a quadratic function reveals different key characteristics. State the characteristics you can determine from each form.
because we already have it on one of our other sheets.
Which sheet?
The one that
Venn
we were just
diagram.
working on.
That, not on the Venn diagram.
I don't know what they're working on.
The Desmos one. That Desmos, and so I would make a note to myself, see the Desmos activity. What was it called again?
Demo activity.
Well, it just says
Forms of quadratic equations.
forms of quadratic equations, right?
I told
The
you.
Desmos lesson that says forms of quadratic equations, that's what we want to be looking at. Okay, so I would just make a note to myself, the forms of quadratic equations, Desmos activity covers all of that. That was cute. Whoever did that. I would assume it was Key Anthony because he likes to do goofy things.
That's why they would hit me on my dad.
Thanks for proving my point.
You gotta start with the day.
Oh. Okay.
Okay.
Almost spit on.
Okay.
When you made that face,
Focus.
you look like the angry moo off,
Inside
Inside
out.
yeah.
So focus really quickly, alright? So this is that extra sheet, that second sheet that I gave you yesterday. You'll notice it's very similar to the very next page in the book. If you look at M1-55, it looks very similar to this. Some teachers and I who were working together throughout the county looked at the problem and we decided that we wanted to change this problem because we felt like this would help us better.
What's different?
I
I see now.
would say, I think
Christine the same.
Christine's is the same, and we made Kate. So I will tell you this, these two equations are equivalent. Meaning that if I were to graph both of them, they'd be the same. They have exactly all the same inputs and outputs, and so we wanted you to see that difference there, or see that idea. So Christine, how did she find the axis of symmetry? What did she do? Well, she had standard form, so she did
Quadratic
opposite of B divided by 2A. Right? It's right here. Notice she used the opposite of B divided by 2A.
Right. Where's the nothing?
Well, I mean, it's already there, but this is that separate sheet that your scissors are sitting on top of, Key Anthony? That sheet?
Oh, snap. But it's
Oh,
Maybe
snap.
you can, but you can't, Anthony.
Emma Erasmus?
Me personally.
Okay. Hey, Key Anthony, it helps when you're turned towards the board that I'm working on.
Right. I looked, but then I was looking at the book. I'm like, why they not the same? But I didn't look at my paper. I was just looking at the book.
Did other people hear me say that this was the extra sheet of paper?
It went through.
Yes.
It went in, out the.
Alright, I need you to focus.
Wait, that's
Okay. Hey, don't be rude. Okay, so she took the opposite of B and divided it by 2A. And so we get negative 12 divided by 2 times 2. Opposite of B divided by 2 times 2. And so we get an x value of negative 3. Now, once you have the x value of the vertex, what do you have to do to
Plug
find the
in.
y value?
Plug it in.
Okay, do you know the more mathematical term for that?
Substitute.
Substitute it in, there we go.
There.
Alright, what was that finger you held up?
She had a
I held up this finger.
You better watch yourself.
Yeah. That's
Okay, so, right, and notice how it says it right here, this is what we want to be careful of. Textbooks, professors are not going to say plug it in. The